Hi all, good morning. Welcome to this module 1 of Introduction to Python tutorial. Previous session we just gone through the topic of coverage. Today we are going to start with data types, variables and the operators, right, related to Python. Now let's see what we are going to cover in this particular module. We'll understand the fundamental concepts of data type, which is primarily any programming language you go in, we need to understand what are the different data types available. Second, once you understand the data type, we also need to understand how do you go and create variables in it, because ultimately when you write programs, right, quite often they're not, you will be using lots of variables and they are going to be associated with specific data types. And third, we are going to cover today is the usage of operators, right? And this operators concept is same in any programming language. We are going to see what are the different operators available, and for each one of these we'll also see the demo. So this is what we are planning to cover in this module. So let's begin with data types. Okay, before that you can have a look at it. One of the comments that I received from python.org. This individual is from Google. So he said Python has been an important part of Google since the beginning and remains so as system grows and evolves. That means Google also say that Python is actually quite vital for their day-to-day operations. Let's move in and understand data types. See, as a programmer, when you start writing a program, right, very rarely you see a program where there is variables are not used, right, unless until we just don't display hello world, right. But as a programmer, we actually keep on defining lots of variable in our program, right. And when you have variables, they must have a specific data type associated with that, because data type tells us that what kind of operations you can do actually on this particular variable. And just like any other programming language, we have plenty of built-in data types. For naming some of them is a numeric data, integer, float and complex. Text data is a string type which is called as an str. We have got a boolean data type which is majorly to store the data as values are true or false. Then you have got something called sequence of data. For this we are going to take up a separate module wherein we'll discuss about list, tuples and range. The next one is called map data. Now those who are from Java would understand this. If you have done hash map, or if you understand a JSON file wherein we store key value pair, right, that is exactly how you do that in Python by using a structure called a dictionary, right. So again, for this also we'll take up a separate module. The next one, you're going to hold the binary data. It could be stored in bytes, byte arrays or memory view. And we have got something called set data. I hope in maths we have covered something called set theory, right? Intersection union we have covered. Yeah, that is set data. It's very rarely used, but still we'll see certain demos in this particular tutorial. So let's start with variables. So you understood that there are different data types are available in Python, just like in other programming language. Now, how about going and defining a variable in Python? Now we create variables so that we can store certain information in it, and later point of time either I can go and modify that particular values or I can refer to them just for display purpose. So variable, you can say it's kind of a container where the values can be stored for our further references. One of the important thing that you need to remember in Python, just like any other programming language, in Python you do not declare variables. So you are not going to define a variable before you go and use it. Python says you directly use it. Internally, I will go ahead and start defining a variable for you, which is called explicit definitions. Take an example here. I have said student name is equal to Ram Patnaik. Now, if you look at that, prior to that I never told that student name is going to be what type. I directly say student name is equal to Ram Patnaik, age is equal to 23, average score is equal to 89.5 and pass is equal to true. The moment you write down these particular lines of the code here, by looking at what value you store, automatically the variable data type is decided. For example, the moment I say age is equal to 23, because I am storing an integer value, the age variable becomes an integer type. Average score I store 89.5, so it automatically becomes a float type, right? So what is the data type of the variable, because I am not defining it, right? So what is this default data type is going to be? The data type is going to be the based on what value that you store inside it, right? So accordingly decide the data type of the variables. That's why we do not go and declare any variables in Python. So there are some of the pointers or notes that you need to remember. Just like any other programming language, when you define variable name, what you can use, what you cannot use. A variable name can contain alphanumeric characters and an underscore. Variable name must start with a letter or an underscore character. Variable names are case sensitive. On day one, I told you Python is case sensitive. So obviously variable names are case sensitive. A variable name cannot start with a number. So these are some of the things that you need to remember when you start using variables inside a Python program. Let's look at the next aspect of it. If you are done through or gone through some of the programming language, you understand there are two type of variables you can have inside a program. It could be a local variable or it could be a global variable. By name it says that local variable is those particular variable which has been defined and can be used within a block of code that is not accessible from outside, right? And so if you have done some program and understood a concept called functions, if you define a variable inside a function, that variable can only be used within that particular function, right? Beyond that particular function, that particular variable dies. Same here also. So it has got a local scope. Second type of variable is a global variable. Those variable which can be accessed across the functions that you have inside a particular program, and typically we go and define those particular variable outside the function. So that is basically defined outside and it is accessible throughout the program, which is basically called as a global scope. So if you take a look at this example, let me take a pointer and just elaborate this. So if you see, I have defined a variable called C global. You can see there is a function I have defined called test global and local. Now remember, this def is a keyword to define a function in Python. Just for your timing, this is how you define a function. We'll have a separate module to cover our functions. Now, because this particular variable is defined called C global is defined outside the function, this variable can be accessible within. But take a look at this particular function body. Inside that, we have defined a variable called C local. Now, because this C local is defined within the function, so accessing that from outside the function is not allowed. That means this particular line, if I write, this particular line will throw me an error saying C local variable is not found. Reason being, this C local variable is defined within a function. The scope of that variable is within that function only. You can't access it from outside. Wherein this global variable can be accessible within the function or outside the function. So the part of the story is whether a variable becomes a global or a local actually decided by where it is defined. Is it within the function or it is outside the function, right? That is how you define a local or a global variable. We will see a demo for this as well. Next is, let's say something more about variables, some of the unique thing that you're going to see it in Python. So just take a look at it. Sometime back I said that you do not go and declare a variable. It's all about how do you store, and accordingly the variables get initialized. So you directly go and initialize a variable internally, it goes and declare a variable for you. Data type is decided for that particular variable based on the value that is stored within it, right? Take an example. I said name is equal to Python because I'm storing a string called Python, so the name variable automatically becomes a string type. Sal is equal to 10,000.5, so sal automatically becomes a float type, right? Right. Now next question comes in, if someone says, you know what, how do I know what is the data type of the variable, right? Because I don't define it. So how do I know? In Python we have a function called type function, right? These are predefined functions available in Python. If you remember on day one I said Python has got so many inbuilt functions. So one of the functions that you're going to see it now is called as a type function. This particular type function actually returns me what is the data type of that variable. So if you look at this particular code snippet here, wherein I have defined 4 variables and I just go and print them. I said type of student name, type of age, type of average score and type of pass. You can see here it says type of student name is an str or a string type. Type of age is an integer type. Type of average score is a float type and type of pass is a boolean type. If you see carefully, I have not defined this variable anywhere. I directly put values into it, right? These are the values I put. So how does it decide? As I said, based on the value that you store inside a variable, automatically the data type decided. How do I know? What are the data types of those variables are at any point of time? Use the type function, right, which is an inbuilt function of Python. You can use it, and you can check the data type of that variable. Now a question can come up in mind, because I don't define variable. So question is, can an existing variable hold different type of values? Now what does that mean? Let us take a case. I have defined a variable called myval, and I have stored an RT. Inside that I stored a value called RT, which is a string type. When I see the type of it, it shows me str. Now in the same program, if I just go ahead and put another statement saying I said myval is equal to 100. Remember, this variable has already been defined. I had a value called RT, which is a string type, and I said myval is equal to 100. The question is this particular line of code is going to work, or it is going to throw me an exception, right? Take your time, think over it, and you can try it out at your end and check whether this code is going to work or not going to work. If it is not going to work, very simplistic reason, because the variable is already a string type and you are trying to put a number type, right? Other way is that because Python variables are auto created, so there could be a possible in myval I can also hold 100. So both the options are, probable options are actually correct. You just go ahead and try them out and see whether it is working or not working. Next one, how do you go and initialize a variable? Now this is not new, right? We do it in any programming language. It is said that before you start using a variable, you must initialize the variable. For example, by principle, what we do, if it is a string type or a character type, we initialize to a space. If it is a number type or a float type, we initialize to 0. So it says that. Now in a similar manner, what are the different ways you can do the initialization? So take a look at it. Here I said a is equal to 10. This is fine. Any programming language does so. Then I say b is equal to c is equal to 15. Many programming languages you do it, right? That means and b and c both are holding 15. So there is no doubt. I mean, this is quite common in any language. Let's take an example 2. This kind of a statement you rarely see in any programming language. Now here you see I am trying to initialize 3 variables. But interesting part of the statement is all the variables are not holding similar type of data. For example, I am trying to put 10, 10.5 and hello. 10 is an integer type, 10.5 is a float type, and hello is a string type. Now question is, Python allows this. Probably something would come up in our mind saying, how come Python allows that? I will explain this particular concept while I cover a functions module. So just keep parking that particular question. In function module, I'll explain how come Python allows this, because there is a small difference in how Python work or how the other programming languages work. So when you say a comma b comma c is equal to 10 comma 10.5 comma hello, what happens is 10 is assigned to a, 10.5 assigned to b, and hello get assigned to c. You rarely find any programming language where dissimilar data type variables are initialized in one line. You rarely find this, right? But Python allows that. So this code is going to work. Next one. There is another function that you're going to discuss about, whose name is called id, right? If some of you have done C programming, then you would have used a concept called ampersand, right, with variables. If you have done, then just try to memorize that and just try to see how it is correlates to id function. Now what does an id function do? It says this, if you read the second line, it says function returns an integer value which represents the memory address of that particular object of the variable. Do you remember in C, how do I get an address of a variable? Let's say I've got a variable called a, which is an integer type. If you remember in C programming, you use an ampersand followed by a to return an address of that variable called a. Exactly in a similar manner, in Python, there is a function called id which returns me the address of that particular variable. Probably you know that every time you define a variable, it allocates a memory for that particular variable, and in that variable you hold a value. So every variable has a memory address. Please remember, there is a bit of a difference you are going to find out in Python. So here in the example one, you can say I have defined two variables, or rather than I say I have initialized two variables, a is equal to 10 and b is equal to 20. So there are two variables defined, a and b. A is holding 10 and b is holding 20. If I wanted to find out what is the address of A and what is the address of B, or a memory representation of A and B, I can write on ID of A and ID of B. Please remember this print function we'll discuss bit later. Print is equivalent to printf in C or system.out.println in Java, right? So just keep that in mind. Print we'll discuss in detail. So print, you can say it's like displaying something back to the user. So when you say ID of A or ID of B, it is basically returning the address of A and B. So if you see that, it returns an address. Now if you observe very carefully, the address of A and B are entirely different. You can just take a look at ID of A and take a look at address of B. Now you would say, okay, this is how it happens in any other language. When you define two variables, it is understood that two variables has to be created in two different memory locations, right? Okay, that's fine. Let's take another example. Here I have defined, if you remember the previous slide, right, I said A comma B is comma C is equal to 10 comma 10 comma 5, 10.5 and hello. There are three variables get defined. If I wanted to get their address, okay, fine. A's address is different, B's address is different. You see here, A's address is different, B's address is different, and C's address is different. Good. Like normal programming language, Python is also behaving in a similar manner. Now let's take a look at the third example. Here I am saying A is equal to B is equal to C is equal to 10. This is fine. We do it in C, C++, Java. Consider A, B and C are integer type in C, C++, Java. We do it. We can initialize more than one variable at one go. That means A holds 10, B holds 10 and C also holds 10. But surprising fact is in the address. Are you all able to see that ID of A and B and C are exactly the same? It is not different. Can all of you see that? Observe that very, very carefully. Okay, this is quite interesting. Now this is one of the best feature of Python. Probably in my a summary kind of a video I'll explain. This is one of the reason why Python runs faster. Now when you say that A and B and C are holding 10, Python is smart enough to understand, oh Ram, we are defining three variables all holding the same value. Why should I create three separate memory locations for this? Why not I will create one memory location and I'll point to that particular memory location. A, B and C will point to that memory location where 10 is stored. Please remember, Python uses a concept called value tagging. So here, interestingly, what Python does in smart manner, he allocates a memory for 10. And A, B and C, in C or C++, you understand the concept of pointer, right? A and B and C are nothing but pointer pointing to that memory location where 10 is stored. That is the reason why A, B and C's address is the same. It actually saves memory, and this is one of the reasons why Python program runs faster. So this is unique. Please remember that this is quite an interesting part of the variable declaration, how it happens in Python. Rest all are same, but this is something different. You are going to find it out. Okay, you can check it at your end. Anyway, I'll share the code which you can run at your end as well. Now coming back to the next part, which is very important in terms of variables, is type conversion. What is type conversion? It is nothing but converting a data type from one format to another format. Let's say I want to convert an integer to float or a string to integer. So you do a type conversion. Now in any other languages, we have both these options available. Either I can implicitly do a conversion wherein I don't ask, programming language does it for me. Sometimes I have to do it explicitly from my end. So there are two ways you can do a conversion. One is implicit and one is explicit. Let's take an example first. So here I have defined two variables. One is called test int, wherein I have stored 788. I have stored test float, which is a 7.88. I'm actually doing an addition operations of an integer and float. So obviously you expect the result is going to be a float type, right? And that is nothing but the value will be stored in test val. So what is your guess? What is the data type of this test val is going to be? Is it going to be an integer? Is it going to be a float? Right? Now you understand that when you add an integer and float, obviously the result is going to be a float type, right? So what Python does, automatically it actually defines this particular test val. As you can see, I'm trying to display type of test val and it says is a float type. So by looking at the kind of operations that I'm doing and expecting what the result is going to come out, accordingly the test val variable get converted to a float type. This is what implicit. Let's take another example. First example looks to be easy. Let's take a second example. Now in the second example, folks, you just take a look at it. I have defined a variable called test str. Okay. And I have defined test str as 788, but it is in double quote. That means it's a string type. Then I have got a test float which is 7.8 as a float type. Now next operation that I'm trying to perform is nothing but adding up a string to a float. Now in any other language it's supposed to throw an exception. In Python also throws an exception. The exception name is called type error. It is typically saying that, Ram, how can I add a string to a float, right? It gives an exception. Now question is, internally I want the 788 which I have stored as a string type. In this operation it has to be taken as an integer type for me. I want that. Now here, if I wanted to convert that 788 as a string to be considered to be an integer type for my operation, then I have to explicitly tell him, right? Take a look at my outcome. Here what I have done, the same code, but you see a small difference. What I have done, I have typecasted this test str into an integer type. See here, I have done it an integer typecasting. Now the result is going to be fine, right? So I know 788 is a string, but it can be converted to integer. So I said int. So explicitly I'm doing a typecasting. So what this slide explains you, it explains you that if you are working with a variable, quite often than not, we need to do some kind of a type conversion. Like any other language, it could be implicit conversion or it could be an explicit. In this slide, you take an example 1 and take an example 3. In example 1, it is an auto type conversion which is implicit, and in the third example, I am doing an explicit type conversion. I hope we are okay with the type conversion now. Now, take a look at the third part that we are interested to cover, is operators. Now, if you have variables, then you need to do operations on those variables. Like any other programming language, in Python also, there are different type of operators are available. For example, arithmetic operator, assignment operator, comparison operator, logical operator, bitwise operator, special operators. In the special operator, we'll talk about two. One is called identity operator, and we'll talk about membership operators. Now, these are the various types of operations that I can perform on my variable. Let's see each one of them in slides. Whichever is easy, I'll just show you and proceed. Wherever there is an explicit difference you find in Python, that I'll explain in detail. So arithmetic operators are fine. We are talking about addition, subtraction, multiplication, division, modulus, and so on. So in this example, you have HAL1 defined as a 5, HAL2 is defined as a 7, and then I'm trying to do different kind of operation. For example, here I'm trying to do a sum, here I'm trying to do a subtract, here I'm multiplying, here I'm doing a division. There is something called floor division, then I'm doing the modulo, and here I'm trying to find out the power, right? So operators are pretty simple. You have got a plus sign, you have got a minus sign, you have got a star, you have got a division, you have got a 2 slashes, which is nothing but floor division. Then this is a modulus operator, and this is 2 star. This 2 star is nothing but to the power, right? Almost same that you see it in any other programming language. So if this is my code, this is what my expected outcome is. Sum is 12, subtraction is -2, multiplication is 35, division is 0.714, floor division is 0, modulus is 5, and power is 78125. I hope arithmetic operators looks to be easy, because it is same as what other programming languages do support. Next one is an assignment operator. Assignment is nothing but assigning a value to a particular variable. So it's pretty easy. Let's take a look at them. So every time you try to create or initialize and update a variable, we just go and use an assignment operator. So I said my underscore number is equal to 42, my underscore name is equal to Ram, total is equal to 15 plus 25, is true is equal to 42 less than 84. Now these are difference, right? You look at the first two examples, or you can consider them to be literal, right? But the third case, I'm actually creating a mathematical expression and assigning a value back to this variable called total. In the fourth case, I'm actually trying to do a Boolean comparison and trying to put the value back to this particular variable as a Boolean variable. So you can do initialization in multiple ways. Directly assigning the value to the literal, you can put a math expression and do the initialization. You can put a Boolean expression and put the value back to the target variable. Anything is fine. Now, what are the different type of assignment can be done? Now base assignment is pretty simple. I said name is equal to Sajjad. This is pretty simple, right? Take a look at the second example. Can I do multiple assignments? You saw in my previous slide. Yes, you can initialize more than one variable at one go itself, considering all of them holding the same value. I say b is equal to c is equal to d is equal to 100. Means all the three variable holds a value called 100. The third one is parallel assignment. This is not possible in many of the programming languages, right? Here I am assigning values to three variables, but all the three variables data types are different. One is a string, one is an integer, another is a float, right? This is rarely you find in any programming language. Last one is an augmented arguments assignments. I hope if you have done C, then you would understand plus equal to, minus equal to, and so on. Yes, that is also possible in case of Python. You can do that, right? So these are the different kind of ways, rather than I'll say these are the different ways of doing assignments to a variable inside the program. Now take a guess, check your knowledge, and let me know what answer it is going to be. So this question has 4 print statement, right? So let me just take a marker. Yeah. So here there is a print statement, here there is a print statement, here there is a print statement, here there is a print statement. I have covered in details, right? So try to memorize what I have covered, and accordingly you can take a look at this question and guess the result. There are 4 print statement. You just let me know which option looks to be true. Take your time, pause the video, have a look at this code, and then guess the result. Is it A, or is it B, or is it C, or is it D? Just pause the video, do it by yourself, and then do it. Okay. The answer for this is going to be the first one, right? Try it out at your end. Try to understand why it is happening like so. And if you have any question, you can definitely put in the chat, right? Now let's move on to the next one, which is called as a comparison operator. Now in programming languages, when you make conditions, right, condition checking, or when you make loops, right, whether it's a while loop or a for loop or a do while loop, you put conditions. When you put conditions, you would understand that you use a comparison operator, right? It could be greater than, less than, greater than equal to, less than equal to, not equal to, right? You can use lot of comparison operator. Now similar kind of stuff is also possible in Python. So there is no difference. You look at here, less than, greater than, less than equal to, greater than equal to, and not equal to. Not equal to is represented by an exclamation and an equal to sign. Even you can write on NOT as a keyword, whichever is comfortable to you. So take a look at an example. I said A is equal to 50, B is equal to 70, and then trying to showcase you that the 4 operator, greater than, less than, equal to, and not equal to. And if you understand the concept of comparison operator by now, this is what the predictable result is going to be. Is it A greater than B? Answer is false. Is it A less than B? Yes, answer is true. Is it A equal to B? No, answer is false. Is it A not equal to B? Yes, it's actually not equal to B, right? That's when answer is true. So take your time, take this particular code, run it, or else you can download my code and run it. Next one is the logical operator. There are many times wherein we need to add multiple conditions together. Whether it's a while loop or a for loop, we need to add multiple conditions together, right? And that is where we use logical operators, right? So use operators like and or. What does an and condition tells me? I am comparing for 2 conditions, x greater than 5, and I am also checking for x less than 15. Now I have joined these conditions by using an AND operator. That means both this particular condition has to be true, so that ultimate output of my print statement is going to be true, right? AND means both the condition has to be true, then the resultant is going to be true. The other option is available to me where I can put an OR condition. OR condition means either the first one is true or the second one is true, the resultant is going to be true, right? I hope all of you understand the concept of a Boolean table, right, or a bull table. Same thing. You can use a not operator before that, so which is nothing but a negate of what the result supposed to get. So you can use and operator, you can use or operator, or you can use a not operator, right? So these are your logical operator which you can use it in Python. Primarily the same concept applies to programming languages, other programming languages, but in some programming languages we use double ampersand or pipelines, double ampersand for and two pipelines for an or condition. If you have done Unix, we use -a for and if you have done Unix, then we use -o for an or condition. So, but then any scripting language or a programming language we work with, logical operators are there. In a different format it is written, but yes, it is there. Next one, we are going to cover up something called special operator. In the special operator, we discuss about two things. One is called identity operator, which is called is and is not. And second one, we'll talk about a membership operator, which is called in and not in operator. Let's talk about is and is not here. Now, here this particular special operator gives you some additional functionality, right? Some programming language has this, many programming language do not have this option. Now question is, what is or what is not, and how I'm going to use it in Python program. Now it says is operator, it returns true if two objects have the same identity, indicating they are the same object, right? So I'm basically comparing two objects. Are they same or are they not same, right? That's how we are going to get a return value, whether it's a true or a false. Take a look at this x and take a look at this y. Don't worry about the square brackets. If you remember in my slide 1 today, I just discussed about a concept called list, right? Anyway, we'll discuss that later also. So think of this particular x is like an array which is holding two elements. One is Python, one is programming. Y is also holding is an array which is holding, let's say, first value is a Python, second value is programming. So you can consider as of now x and y is like arrays having two elements inside it. Then I'm saying z equal to x. So what I'm doing is I'm creating a variable called z, and whatever the x I have, that I'm assigning back to z. I'm saying, is this x is z? I mean, I'm trying to say, is this x is equal to z? Is it same, right? The second example okay, I'll just show you that. Okay, we'll try to run this and see that. So here I'm using the same thing, but I'm using is not. If you see this demo here, I'm talking about is not. Is not is just opposite of the is operator. It returns true if two objects have different identities. That means if they are different, then it returns me true. It's just opposite of an is operator. So comparing two objects for similarity, it can be done with an is or can be done with is not. It's just negate of each other. You can do that, right? Does other programming language support that? Answer is yes, but there are programs to be written or the codes to be written to do this. But you can do it in one line in Python, either using is or you are using is not. The next identity operator is a membership operator. Now, those who are coming from an SQL, right? If you have written a basic SQL, you would have used this in operator, in, not in an SQL statement, right? If you have done Java also, you would have used in and not in operator. But let's see what is this in and not in operator does. This particular membership operator checks a value in a sequence or checks it in a collection, right? I mean, if you've gone through my first index or TOC module, then you would have understand I discuss about something called the string, list, tuples, and set. Yes, we will discuss about that. That is actually called as a sequence. If you want to find out a similarity of this in Java, you talk about something called array list, right? Hash map. You would have done that, right, in Java. Something similar to that is nothing but string, list, and tuples. We will see that. Now, what is an in operator tells me? In operator basically is going to return me a true if that string that I am searching for is found in a sequence. Let's take an example. Question is, you accept your name and check in your name whether vowel E is found or not found. I wanted to check in my name whether vowel E is found or not found. If you're doing it in a C or C++, you actually create a loop, take one character and keep on comparing with E, right? That is one way you do it, right? Python says nothing doing. You just directly use an in operator and just one line of code, and I'll give you a result whether it is found or not found. Take a look at this. I have a string defined called text wherein I have stored hello, welcome to this particular course. I'm trying to find out whether welcome in text. That means I'm checking whether welcome is actually found in text or not. Now in this particular text, do you find a welcome? Answer is yes, but I told you Python is case sensitive. If you look at very carefully here, this welcome, this W is small, right? Wherein this particular W is capital. That's why it returns me false. The next statement says this in text. In hello, welcome to this course, do you have a this as a keyword found? Answer is yes, it is available, returns me a true. Look at how easy it is. In any other programming language, you have to write down a loop just to check whether a string is found in a main string or not. We used to do that, right? It's a longer program and we used to do that. Just opposite of in is nothing but not in. Right? In says if it is found, it returns me true. Not in says if it is found, I will return a false. So not in means I'm saying it should not be found in the string, then return me a true statement. So just opposite of in is called as a not in. So you can see the same thing, right? I mean, here you see I got a result as false and true, the same code which I'm running now, but I have changed that operator as not in, and you can see the result is now just opposite of the first one, right? So membership operator basically check the instance of a substring in the main string or search for a sequence or a string inside a sequence or inside a collection, right? Let's move on. So whatever you have covered by now, let's go ahead and check as a demo. So let me just go back to my browser. If you are able to see that browser, just let me know. Yeah. Okay. So whatever I have covered, I have created in this Jupyter notebook, which I'll put it into my GitHub. So here you just take a look at, these are the 4 variables I have defined. I'm printing the values of them. Just let's run this. It's okay, fine. I wanted to find out the data type of this particular 4 variable that I have created. Remember we discussed about a function called type, right? Let's run this now. Right, it says Ram, student name is a string type, age is an integer type, average score is a float type, wherein pass is a boolean type. How it is decided? Based on what value you have stored. Next one. I have this the question was there in the slide. I said my value is equal to 10. I am going to print that, right? It says okay, it is an integer type. In the same program, I am trying to put my value as an RT. Now, originally it was an integer type. We were trying to put a string value. Is it going to work or it is not going to work? Take a look at this. My value is equal to RT. What happens? Based on the current value that you store, the my value data type has changed to string type. So this is possible. You can do that. Right? Now let's take about this. This is fine, right? I said name is equal to hello. This is like initialization we do. Name is equal to hello. Name is equal to test. Now here you just take a look at it. It's a case sensitive. Here name is in small. Here n is capital. When I print name, it displays me hello. When I print name in n capital, where I can print a value called test. In slide we said, right, case sensitive, variable names are case sensitive, need to be very, very careful on that. Next, we also discussed about a concept of a global variable and a local variable, right? So if I just go ahead and run this, it says local variable is this, it is inside the function, and global variable you can access it outside the function. Now question is, how about going and printing this? I just print this C local now, and this is outside the function, okay? So if I just go ahead and run and just print it, I hope all of you can see, right? There is an exception raised. He's saying, Ram, what is C local? I don't know. In line number 8, you are trying to print a variable. I don't know what this variable is, because this C local variable was defined inside the function, and you are trying to access that variable outside this particular function. Because it's a local scope, obviously this particular variable is not found. I hope it is now clear to all of you. Saying what do you mean by saying local variable and a global variable. Now coming back to the variable declaration, I think this is the same demo I showed you in a slide. How about defining or initializing the variable a equal to 10 and B and C is equal to 15. If I just go and run, you can see B and C is holding 15 where A is holding 10. Good. This is unique, right? Here you are trying to initialize more than one variable in one line, but they are of different data type or dissimilar data type. Programming language don't allow that, but Python do. And you can see here, A is holding 10, B is holding 10.5, and C is holding hello. Now, take a look at this. A is holding 10, B is equal to 20, and I am explaining a concept of ID method. Now, because these two variables are holding two different values, if I just go and run this, you can see their address is different. It is 5688 and this is 6008. Reason being, these two variables holding two different set of values. Now let's talk about an ID of three variable which are of holding different type of data which has been initialized in one line. Right? They are different. A is different, B is different, C is different. Now the third case. What if all the three variables are holding the same value? What is their ID is going to be? Take a look at this. Do you see all the addresses of A and B and C are the same? Observe this very carefully. The addresses of A and B and C are same because it is holding the same value. Right? This is the question I asked you to do it. So you can try it at your end and let me know. Right? Talking about type conversion. This is an integer, this is a float. So adding an integer and float is not going to be a problematic one. So if I just go ahead and run, yes, it says run. The result is this, and the data type of the resultant variable is a float type. But when I just go and run this particular code, it will cry, and the cry is saying type error. And I do not know how can I add a string to a float. This is a string type, this is a float type. I don't know how to add. Fine. So I missed it. I should have told you that this particular string value that I am passing, it's actually consider that as an integer and do a calculation for me. So I said, okay, let me do one thing. I will do a typecasting from my side, which is nothing but explicit typecasting. Now if I go and run, am I getting the result now? So this is your explicit typecasting you are doing. Based on your requirement, whether you can do a typecasting to integer, float, boolean, whatever it is. Here I wanted to convert to an integer type, so that is why I did an integer typecasting. This particular concept is there in other programming languages as well. Next we covered up operators, right? And this is an example of arithmetic operator. There is no difference you find compared to any other programming language. These are pretty simple of saying plus, minus, multiplication, division, float, division, modulus, and power. This is how you do an assignment. Right, this is a literal assignment, this is a math expression assignment, and this is a boolean expression assignment. Right? Then we talked about what are the different type of assignment is possible. One is a base assignment can be done, multiple assignment can be done, parallel assignment can be done, or you can do an augmented assignment as well. Right? We saw that in slide. Coming back to comparison operator, we discussed about greater than, less than, double equal to, not equal to. Right? So same code I'll be sharing with you. You can just take a code and do the changes, or you can run as it is. Then we discussed about logical operator. Logical operators like and or, and over and above that I can use a not operator. Same. So if I just run, you can see that. Is that x value is greater than 5 and x value is less than 15? Look at your x value is 10. So this is actually greater than 5 and it is also less than 15. So the return result is true. I am saying x greater than 5 or x less than 2. Now in this only one of the condition is true, but still then because you are joining with an or, the resultant is going to be a true. Opposite of what x is equal to 10, I use this, I use a not over and above that. So whatever the result I got in the first example, I would get the just opposite of that, which is nothing but false. Right? Then we talk about special operator. Okay, my mistake. Special operators, right? Here I have got an x and y. I am initializing the x back to z as well, and I am trying to say, is this x is y, x is z, is it x is y, is it x double equal to y? If I just go and run this, you see this. Is this x is z? Because you see here I have initialized z by taking the value from x. That means x and z referring to the same placeholder, right? It is true. Is x is equal to y? No, no. X is a separate variable. Y is a separate variable. That is the reason why it is false. Is x double equal to y? Double equal to in the sense that the values, if the values of x and the values of y are the same, answer is true. Right? Answer is true. Opposite of is or is not. Then we discussed about a concept called in and not in. This is pretty simple. I mean, this is probably the easiest thing you can do. Similar kind of stuff can be done in C or C++ Java, but we write a bigger program for this. We need a loop to do all of that. But in Python, it's a single line of code, in, and this is an example of not in. Right? This is exactly what I covered, guys, in my slide. I hope what I covered in the slide is okay to all of you. Right? I'll be sharing my demo code in my GitHub link. You can download and test. You can modify that as per your requirement and test them as well. So what we covered in this module? In this module, we covered data types in Python. We discussed about how do you go and use variables, what are the different ways the initialization can be done in variable. We also find out something interesting of variable initialization which no other programming language support. And the last and most important thing that we covered is nothing but what are the various operators and how do you go and work with them. Right? These are the three things we covered in this particular module. I hope it is okay to all of you. Revisit this particular video again and just brush up that. So that's it from my side for this particular module, guys. Thank you all.